Let's have a look at an interesting CAM application. Today we'll be discussing solids-based machining and explore EDGECAM's unique approach. Solids CAD design is very widespread. As a result, a common assumption is that solids-based machining probably is an essential capability for any modern CAM system. If the requirement is simply to load a solid into CAM and the end result is toolpath, then many CAM systems do measure up. At Hexagon, our most productive EDGECAM customers expect more. EDGECAM has offered industry-leading solids-based machining for many years. The secret to EDGECAM solids machining is a combination of technologies that directly open solid models, leverage a high degree of model information, and allow for CAD to toolpath associativity. The result is a reliable, fast, and flexible approach to solids-based CAM that benefits users across the mill, wire-EM, and turn application spectrum. Let's explore EDGECAM's intelligent solids machining approach and begin with two typical milling applications. We'll begin by working with a prismatic solid for a vehicle bracket. I've used the drag and drop technique to open the solid and could have also used the file open command. EDGECAM can open a wide range of files, including directly opening solids from many CAD systems, various solid data translator formats, and wireframe. Regardless of the file type that you open, once the solid is opened in EDGECAM, the workflow is consistent. Here, EDGECAM has already collected quite a bit of information about the solid and oriented the model to a convenient position. We'll adjust the part orientation to better suit our needs. Now we'll add a stock component, in this case, rectangular material suitable to both the part size, which EDGECAM has already analyzed for us, and the manufacturing requirements. The datum will be moved to be in the middle of the part volume. And then we'll add a self-centering vise from our database, which stores the common work holding fixtures for our machine shop. Notice the vise automatically opens up to the stock size that we're using. And then finally, we'll select the intended CNC machine to complete the virtual CAM setup. We're off to a quick start with a new machining operation. EDGECAM previews that for us, and since it looks like what I intended, we'll turn off the display of the machine and the fixture temporarily and move to feature recognition. At this stage, we're going to use EDGECAM's excellent automatic feature recognition capability to find the machinable geometric regions in this solid. The EDGECAM user retains control and has ability to tailor results so that the features are always best suited to the necessary machining operations. You can see at the end of the process there are a variety of features created. So at this point, let's say that we just got notification that there has been a design change. The designer has improved the component to reduce the weight of this vehicle bracket. So we're going to replace the solid we've been using with an updated model. And notice that EDGECAM updates the solid, maintains the machining orientation, updates any existing features affected by the change, and also finds new features. There are new pockets for the weight reduction. Notice this open pocket feature. Regardless of the CAD design method used to create this geometry, EDGECAM is not confused about the manufacturing implications of this feature. When we view its properties, we can see a great deal of information has been collected, including things like the smallest fillet in any corner, the radius along the floor, and other useful info. This data can be used to speed up any manufacturing process. Now that's not something we're going to cover here due to time, so we'll jump forward to completed toolpath and look at what happens when we have a design change. So toolpath for the machining operations is completed, but during that process we noticed that some of the weight reduction pockets in the new design join directly against the hub. This isn't ideal and could be improved. We've talked to the design engineer and there's been another design change. So as before, we'll simply reload the latest solid. The updated model is swapped in and EDGECAM immediately evaluates the features. These changes do not affect our current machining process, so we'll simply accept them and move forward. Next, we'll go rebuild that machining process, which updates the existing toolpath to the model. The current view has isolated the toolpath in these pockets for visibility, and notice the results when the toolpath is rebuilt. It's now updated the existing toolpath to work with the latest solid. We're ready to now immediately move forward, generate code, and then send that code directly to the CNC machine. Next, we'll look at a rotary indexing application. I'm going to open a new solid, and manufacturing will be done in a 5-axis capable CNC machine, which will permit machining from several different index directions. We'll direct EDGECAM to identify features from 3 model faces, which will help determine index direction. The result is that features are created in 3 different work planes. Those work planes will allow EDGECAM to machine from the top side, the side with the cross hole, and the side with the angled pocket. The CAM user will not have to know any of the actual index angles. So let's jump forward to after toolpath has been created to see the results. We'll look at simulation first and then NC code. Here in simulation, we're observing the deburring and spot drilling portion of the machining operation. This work on the top side of the part, which is the 0 position of the rotary axes, is nearly complete. The final work at this index position is to deburr the slot that's at the floor of the large open pocket. The tool then retracts to a safe position and indexes to the required index angles to deburr the open pocket, and then the final index position to where the cross hole can be spot drilled. That looks exactly like what we intended. So now let's go look at the CNC code. So I'll build a complete code file, but then we'll jump right to where tool 20 kicks off. So notice that in this section, we begin with positioning to 0 degrees. We'll now search for the next index position. And we can see in the comments that the CAM system knows the correct rotary axis angles for output, but this machine uses coordinate system rotation to command rotary axis movement, and the code required for that is correct too. Regardless of the CNC code programming requirements, EDGECAM correctly calculates the required values. At the next index where the cross hole is spot drilled, we see the correct NC code again. The EDGECAM inputs to drive rotary axis indexing are very easy to use. The CAM user simply selects the desired work plane as the index target. In this case, those work planes are part of the solid model information which were collected during feature recognition. Next, we'll demonstrate how EDGECAM's intelligent solids machining can produce fast results for turning applications. The process for turning is similar to milling and is very fast to put together. EDGECAM begins with orienting the solid when the model is opened. By leveraging what EDGECAM already knows about the solid, we can quickly select a stock size that is suitable for the machining operation we're about to do. And based on the short stock selected, we'll flip the part. And then we can also choose a hole feature in this case to clock up to C0. Next, we'll pair this to the intended CNC machine to complete the virtual CAM setup. Let's have the machine grip the part an inch behind the datum. And with that minor amount of effort, we now see visual confirmation of our CAM setup. We're ready to leverage EDGECAM's automatic feature recognition. So we'll input our preferences to direct creation of the cross-sectional features suitable to the turning portion of this machining operation. We also have ability to go to the Mill tab and direct the types of live tool features needed. This could include advanced features such as radial holes. We don't have any radial hole patterns on this part, so we'll turn off that option. We can see that EDGECAM detects the cross sections for turn, face, and bore work needed for this part, and even the group of rotary holes. This is a good opportunity to mention EDGECAM's knowledge-based machining. In many turn parts, the major components of the machining process are often very repeatable, regardless of the part geometry. So let's adjust the process plan to finish the bore immediately after roughing. Since we're using self-centering drills, there's no need for a spot drill. And using this as our process plan, toolpath is automatically created using a feature-based machining approach. Now that toolpath is built, let's show what happens if there was a late design change. Let's reload the solid and swap in a new model. Notice that EDGECAM updates the solid and reports which features are impacted. In this case, it's all of the features. Changing the stock rendering will make it easier to see some of the changes. The bore diameter has changed, holes have a different bolt pattern, and there are also other less noticeable geometric changes. But the current machining process would work, so we'll just direct EDGECAM to rebuild it, and the toolpath automatically updates to the current model geometry. So let's remove the flags that identify which toolpath events were affected by the design change, and we now have a part that's ready to generate code so that we can move forward with CNC machining. These demonstrations highlight applications where feature-based machining is an essential part of the CAM toolpath. EDGECAM's solids machining capability is excellent in these applications and also in more complex work. EDGECAM's approach to solids machining allows users to build toolpath using any solid, regardless of the CAD system the solid was built in or the techniques used by the design engineer. Front-end CAD is not required with EDGECAM, as you probably noticed with these demonstrations. However, solids that are not manufacturable can be an obstacle to solids machining. EDGECAM Designer is a solution to this challenge. Designer enables users to quickly modify existing solids and create fresh models. Hexagon technology and expertise is helping our customers improve manufacturing processes and improve product quality. We invite you to bring us your machining challenges.